Hey guys, it's Mr. Cole, and today we're going to be working with verifying or proving trigonometric equations using trig identities, okay? So let's just get started, and I'll review some of the trig identities along the way. So whenever you start out a trig identity like this one that you see here, sine squared theta over cotangent of theta minus tangent of theta equals negative sine theta cosine theta. So basically what we're trying to do is we're trying to verify that this equation on the left equals the equation on the right? So the very first thing that I see is you want to get rid of anything to do with tangent, okay? We want to change anything to do with tangent to cosine and sine, okay? So if you're unfamiliar, tangent of theta equals sine theta over cosine theta. Also, cotangent of theta equals the exact opposite. You're just going to flip it. They're reciprocals of each other, okay? So they're cosine theta over sine theta, okay? So what I'm going to do is I'm going to substitute these values on the right over here in wherever I see these tangent and cotangent values, okay? So let's start with that. So I'm just going to copy it down and substitute them. Okay, so here we have cotangent of theta. So I'm going to plug in this part right here. This cosine theta over sine theta. Okay, minus, and then we have tangent of theta, which is sine theta over cosine theta. Okay, and I'm not going to take down the right side of the equation just because I'd be copying it over and over and over and over again. Basically, we're trying to get this left side of the equation to look like the right side of the equation, right? So let's continue on, right? And honestly, with these kinds of things, don't be discouraged if you kind of have trouble with them to begin with, because they're really tricky. They're kind of like puzzles, and you'll get better at solving these puzzles, you could call them, with more experience. So really, if you're having trouble with these, just practice, and you'll start to kind of see the patterns. So let's move on. Here we're dividing by a fraction, right? I'm going to pull this part right here off to the side over here so we can just focus on it real quick. And when we divide by a fraction, right, you have to remember that we need to multiply by the reciprocal, right? So here we have sine squared theta over 1 multiplying by the reciprocal of the denominator, right? So we're just going to flip it and multiply by it. So now we have multiplied by sine theta over cosine theta. So all I did was I took the reciprocal, this part down here, and I flipped it, okay? And that'll tell us what this part equals. And we multiply across, and we get sine cubed theta now over cosine theta, right? So let's rewrite this part in, okay? And this part are the same at this point, right? I just simplified it a little bit. So let's rewrite it. Sine cubed theta over cosine of theta minus sine theta over cosine of theta. And now we have the same denominator, right? So we can subtract them. Sine cubed theta minus sine theta. And they can both go over the same denominator because they are the same, right? So here we run into a problem, and obviously this is not this. Is not this, right? So we need to keep going. What I see is we have a whole lot of sine going on here, and what I'm gonna do is I'm going to factor out a sine theta from the numerator, okay? So I'm gonna go sine theta times, right? So I'm factoring it out. Minus 1, right? Still over cosine theta, right? Okay, now hopefully you've seen something similar to this before, right? And that's going to be our other trig identity, which is cosine squared theta plus sine squared theta equals 1, right? Now what I'm going to do is I'm going to get sine squared theta minus 1 on one side of the equation, and I'm going to get whatever's left on the other side of the equation, and then see if we can substitute it in where we see sine squared theta minus 1, okay? So I want to get this minus 1 with the sine squared theta. equals 0 now, right? But I also want to get this this cosine squared theta on the other side because I want this part by itself so I can plug in whatever the result is into here, okay? So I want to get this part right here, oops, by itself so I can plug in right there, right? So I'm going to do that. I'm going to isolate that part. Right? And now what we're left with is sine squared theta minus 1 equals negative cosine squared theta. Right? So wherever we see sine squared theta minus 1, we can plug in negative cosine squared theta. Okay? That part. Right there, right? Now these little brackets, you guys don't have to write that. That's just for me to easily point out to you guys where I'm going to put stuff. It's not a mathematical notation. Don't worry about writing these little brackets that I'm doing. It's just to emphasize for you guys, okay? In fact, don't write them on any of your tests or anything, okay? It's just for easy clarification because online it's a little bit more difficult to emphasize exactly what I'm talking about. Anyway, back to the problem. We have negative cosine squared theta we say is the same as sine squared theta minus 1. So we can effectively plug this in wherever we see sine squared theta minus 1, which is right here, right? So let's plug it in. Substitute it, right? Times negative cosine squared theta over cosine theta, right? And now here, right, because cosine squared theta is the same as, I'll write it down here, is the same as cosine theta squared, right? So what we can do is we can divide them, right? Because now everything's multiplying by each other, we can divide them, right? So we'll divide by a cosine, right? And that the squared will go away. And what we're left with is negative cosine theta sine theta, right? Which is by the commutative property, right? Because this is what we started with, or this is what we wanted to get to up here, right? Commutative property, they're the same, okay? So we can flip those around because they're just multiplying by each other. I'm pretty sure it's commutative property. I might be wrong, but some mathematical property. And here we can see, yes, it does equal negative sine theta cosine theta, right? Hopefully I got everything in frame. If you guys have more questions about this, I'd be more than happy to answer them because these are tricky. These are very, very tricky. And you'll only get really, really good at them and fast at them after you've done a lot of them. So if there's any that you guys have problems with, feel free to email me and I'll try to grind them out as quick as I can. But yeah, you guys just gotta practice these. These are kind of difficult. Trust me. Anyway, I hope you guys are being safe. That's about it for the video. So take care, guys.